Good day to Doctor. My name is Chong Metri number AE190094. Today I'm going to present about the assignment 1, Intrinsic and Distortion Parameter Determination from the smartphone. In this assignment, I will determine the intrinsic and distortion parameter in this full model, which is the iPhone XS. I'm using the F26 checkerboard with a 25mm dimension for each square, and I take 12 images of the checkerboard with a different angle and different distance between the checkerboard and the cameras to apply in the camera calibration apps in the MATLAB. Next session is the demonstration of camera calibrations in the MATLAB. Now I'm using the camera calibrator apps in the MATLAB to determine the intrinsic and distortion parameter in the iPhone XS camera. So first we go to the Add Images. And we select all the image of the checkerboard that we taken by using the iPhone XS camera. So the size of the checkerboard square is 25mm and the image distortion we will set low. After we insert all the images, it will undergo the analyzing process. After done the analyzing, we can see the detection result. So the total image process is having 12. And the partial detect checkerboard is having 1. That means each image having the 1 checkerboard image, and there is not any rejected image. So from the image of the checkerboard, we can see this is the starting point, which the coordinate is 0, 0, and this is the x direction, and this is the y directions. In order to obtain the intrinsic and distortion parameter, we go to the options. The radius distortion, we choose the 3 coefficients, and we compute the tangential distortion in order to look at the distortion parameter. After that, we click on the calibrate. It will run the calibration process for the all 12 images. After done the calibrations, the reprojection error, pattern centric and camera centric result will automatically generated. First, we look at the reprojection error. What is reprojection error? Reprojection error is the distance between a pattern key point detected in a calibrate image and a corresponding world point projected into the image. So we can see the reprojection error for the images, and we can see that the overall mean error is around 1.66 pixel, which is having a high reprojection error, because normally the overall mean error it should be around less than or equal to 1 pixels. And next, the pattern centric and the camera centric is illustrate the position of the camera while taking the checkerboard image. So when we click on this, so for image 4, it will show the directions of the camera and the position with the coordinate when taking the checkerboard image. Next, we look at the full details of the intrinsic and extrinsic parameter. We click on the export camera parameter. We export the parameter to the workspace. So the camera parameter variable names as the camera params, and we click OK. Then we go to the workspace. So this is the camera params with the property. So in order to obtain the camera intrinsic parameter, we just type the camera params dot intrinsic. It will generate the intrinsic parameter data for the iPhone XS camera with the focal length, principal point or known as the center of projections, image size, and the distortion parameter, which having the radial distortion and tangential distortions. So in order to look at the intrinsic parameter, we just type the camera params dot the rotation matrices, and we will obtain the 3 times 3 matrices for the each image about the rotational matrix. And in order to obtain the rotational vectors, we just type that using the camera params dot the translational vector. It will count out the translational vectors from the image 1 to image 12. So that's all for the demonstrations. After done the simulation, let's see the result obtained from the camera calibrator apps. First, we look at the intrinsic parameter. So in iPhone XS camera, it's having the focal length of 3109 pixel in x directions and 3108 pixel in y directions. And its principal point, or known as the center of projections, have 2017 pixel in x directions, 1503 pixel in y directions. And its image size having 3024 x 4032 which is approximate to 12 megapixels of the image taken from the iPhone XS camera. Next, for the radial distortions. In iPhone XS camera, if having the radial distortions, which the data show is greater than the 0, that this is due to this spherical shape of the lens. When the light passing through the center of the lens will undergo some refractions, which will cause the image become distorted. So for the tangential distortions, it shows as is 0, so we can assume that there is no tangential distortion exists in the iPhone XS camera. So for the extrinsic parameter, by using the command of camera param stop rotation matrices, we can get the 3x3 matrices from image 1 till image 12. And the second intrinsic parameter is the translational vectors. By using the command of camera param stop translational vector, we can get the translational vector in x, y, z positions from the image 1 till image 12. So that's all from my presentations. Thank you.
Assalamualaikum and good evening. My name is Muhammad ROSLAN, my number matric DE190017. So this assignment we're going to do the assignment 1, camera calibration. So I use my phone is Samsung Galaxy S20 Ultra. So the main camera that you can see 108 megapixel for the wide, 48 megapixel for the periscope telephoto, and 12 megapixel for the ultra wide. This phone has super steady video, 0.3 megapixel TOF 3D, frame 0.1 depth. For the feature for this phone, got LED flash, auto HDR, and panorama. So next, this is the checkboard image that I snapped from the phone, top to the left, the first picture, and bottom right for the last picture, the 10. So this is the demonstration of camera calibration in MATLAB that I have done. Okay, this is the picture that I've screenshot. So this is the project error. You can see the 1.55 is the overall mean error. Okay, the right one, the pattern centric. Okay, that you can see. After that, camera centric. Okay, here is the result for the intrinsic and extrinsics. Okay, next. Okay, from that we got that intrinsic metric. Here is the camera param isometric, have match here and here. After that, we go to the camera param intrinsics. We got same result. Okay, after that, we use the params rotation matrix. Okay, here the photo 1, anti-photo 10. So next, the last one, we use camera params translation vector. Alright, here's the result. So I will demo how to do the calibration. First, we need to go to the folder. We need to open the folder. Save vision system. Okay, select folder. Okay, here the first one we need to download the toolbox. The toolbox first. Here, toolbox ellipse, and then we save the picture. Here we need to put in the toolbox ellipse, and then connect here for picture. After that, we go to the apps. We go to the camera calibrator. Wait until pop up. Okay, after that, we add image that we save. Okay, we select all, and then we open. Okay, here we choose pattern checkbox, size of checkbox square 25 millimeters, image distortion low, and then we click OK. Okay, detecting checkbox in image 1 of 10. So from the phone, I use my phone S20 Ultra, snap the 10 picture of the checkerbox. Okay, done. Here the checkbox. And you can see 1 to 10. Okay, after that we need to go to the option. We choose 3 coffins. After that we calibrate. Okay, after we calibrate, as you can see, okay, the mean error, the highest mean error is number 3 here. Number 3, the project error, the highest one. The lowest one, number 6. You can see 6 at 0.72. The highest one, 1.54. Okay, here the pattern centric and camera centric. You can see. Okay, the pattern. When we click the number 1, you can see here the number 1, the bold one. Number 2, as you can see, number 2, number 3, number 3 at here, number 3 here, and number 4, 5, 6. Here's the position that I snap. The picture 6, 7, 8, 9, and 10. Okay, done here. The image. Okay, after that, we export camera to parameter. Okay, here you can see we can rename, but we just put camera params. Okay, and then we click OK. After that, you can see here camera params. We minimize. Okay, as you can see, the camera intrinsics, camera extrinsics, the accuracy of estimation, we project. Okay, before that, before we do the command window, we go to the double click here, and then we can see the image size 3000, 4000. So the radius distortion, you can see 0.0295 is K1, negative 0.4626 is K2, and 1.119 is K3. Okay, for the instant metric here, okay, we double click here. Okay, from here we can see the metric from the node. Okay, we divide. As you can see, using metric notation, the 1 is fx. Okay, the fx is, what is fx? Fx radial distortion frequency. Yeah, it's okay. Okay, it's okay. So the 1, 2 is 0 here. The OX is 2.023. We can double click here. We can see full 2.02361. And then FY here, OY here, and the last one 001. Okay, we go back to the camera param. Here the intrinsic metric focal length principal point must same as common window. Okay, after that we need to command that we use is camera params. Okay, here capsule. Okay, param need same the text. Okay, camera params dot intrinsic. Okay, intrinsic. Okay, we go. Okay, as you can see here, the focal length here 3.0621, same like here. Okay, 3.59 here, and the principal point 2.023 here, and 1.474 3E here. Alright, the image size same 3000 for 4000. Alright, next we go to the camera extrinsics. Okay, we use the camera parameter. The first one is camera params intrinsics. Here, intrinsic, and then we go to extrinsics. We need to put rotation matrix. Okay, we go camera params, and then rotation matrix. See, got all of that. Okay, enter. Okay, here, right? We got the answer for the image, the matrix the matrix rotation here. Picture 1 until picture 10. Okay, we have two extrinsics, and number 2 is translation vector. Okay, we use another command, camera params, translation vectors. See, enter. Okay, here the camera params translation vector. Okay. So this is the demonstration about this assignment. That's all. Thank you so much.
Good day, so doctor. My name is Wong Si-Hui, matrix number AE190146. So our first group assignment is related to the intrinsic and distortion coefficient parameters determination from smartphone, where our task is to use the calibration software, where here we will be using MATLAB software to determine the intrinsic and distortion coefficient by snapping the checkerboard given using our smartphone as shown in the image here. So for me, I'll be using Samsung Galaxy Note 10, which consists of triple camera with its specification listed here. For this assignment, I snap a total of 13 images on the checkerboard, including the image I have shown you previously. Now, I'll proceed with the demonstration of how I will simulate for the camera calibration on the checkerboard images using MATLAB. Basically, a camera calibrator app is able to support the checkerboard to extract the key points. So after we have entered the MATLAB interface, we will go to the apps on the tab above and search for camera calibration app. So after we have clicked on the camera calibration, it will bring us to another interface where we will be uploading the related images we have snapped previously into the data browser. Where the image properties pop up, we are required to set the size of the checkerboard space, which is 25mm, as listed in the assignment paper, and click for low for the image distortion if we think that our image is not that distorted. Then we will wait for it to finish loading, where here we can see that whether our image is suitable or being rejected. Here we can see that we do have one with partially detected but still acceptable to be used for the calibration. So here are the images that we've uploaded before the calibration. You can see that there are a total of 13 images that I have already said previously. The corners of the alternating white and black squares will be used as control points and detected on 2D calibration image by using the corner detector algorithm, where we can see that it assumes the lower right point of the top left square is the origin, and with that determine the 3D coordinate of points for the checkerboard. So after we have clicked on the calibrate button, the MATLAB camera calibrator will help us to calibrate on the images, and various information can be seen. The graph here illustrates the 3D visualization for world-centered views of the calibrated camera, while the next graph here is camera-centered view, where both describe the location or angle of the camera in 3D scene for the extrinsic parameters. From the histogram here, we can see that the one with the highest is the 13th image, where it is actually the one that can be partially detected by the app, which means that it is actually not a goodly taken image to be detected with the high mean error. Later on, we will be proceeding to the export camera parameters into the MATLAB workspace, and the data will be transferred to the MATLAB interface. So by typing related instructions, such as if we want to look at the intrinsics, we can type camera params.intrinsics to display the data. And it's the same for the rest, where if we want to look at the extrinsic parameters, we can use camera params.rotational matrices or camera params.translation vectors for the informations. Besides that, we can also look at the others like the estimation intrinsics and extrinsics error as well. So the slides over here shows the informations that we can get from the exported MATLAB. So the slides over here shows the first exported parameters that is transferred from the camera calibrator, where we can see that there are camera intrinsics, camera extrinsics, accuracy of estimation, calibration settings. So by typing the related instructions, like here, if we want to see the camera params.intrinsics, and it will shows here there will be focal length, the principal point, the image size, the radial distortion, the tangential distortion, skew, and the intrinsic matrix. By typing the intrinsic matrix for the instructions, then it will show us in the matrix form, which consists of the focal point and the principal point. And for the extrinsic parameters, there are two instructions that can be typed in, which is camera params.rotational matrices and the translation vectors. So there will be 13 matrices for the rotational matrices, where it's shown here, and this is the translational vectors. Then if we want to look at any extra information, we can type in estimation errors dot intrinsic errors, and then we can see on the focal length errors, principal point errors, radial distortion errors, as well as the tangential distortion error. And the same for the extrinsic parameters errors for both rotational vectors and translational vectors error. We can also get it from the instructions if we type into the MATLAB interface. That's all from me. Thank you.